differential equations 1 and 2, and finally complex variables. Now, today class. So, the first definition, what exactly this complex function? If certain rules be given by means of which it is possible to find one or more complex numbers, that is denoted by W, for every value of Z. Z is a complex number. For every value of Z, if we have or if we assign one or more complex numbers, such complex number denoted by W. So then this is related to definition of a function. Then W is said to be a function of complex variable Z. Just like real variable function Y is a function of X, here complex variable function W is said to be a function of complex variable Z. And we write W is equal to F of Z. We know that Z is equal to, if they do not mention Z value, you have to consider as X plus IY, comma, F of Z. F of Z is nothing but W. That is, X is related to Y in real system, Z is related to W. W will be of the form U plus IV, where U comma V are functions of X and Y. U is called real part of F of Z and V is called imaginary part of F of Z. Just have a look, simple function. Let W is equal to Z square. So this is polynomial function, square function, that is F of Z. So W is a complex function of Z variable. Now let us see how to find U and V, which are respectively real part and imaginary part of W, and both are functions of X and Y. So just convert into Cartesian, X plus IY whole square. So it looks like A plus B whole square, that is A square plus B square plus 2AB. X square plus I square Y square. I square value minus 1 plus 2AB. I into 2XY. I can put X square minus Y square for one bracket and 2XY for another bracket. Since I is equal to square root minus 1 implies I square is equal to minus 1. So this looks like W is also a complex variable whose real part is denoted by U of X comma Y and imaginary part is denoted by V of X comma Y. So finally UV are functions of X and Y. Now the new definition after differentiable function, continuity function, just like real variables, here also differentiation, continuity of real function. But our interest is the new definition, analytic function. In real number system, the function is analytic, means the same function is continuously differentiable. But in complex variables, there is a lot of difference for the definition analytic function. So first we define the analytic function at a point Z0. Later in the domain or in the region R. A complex valued function F of Z, just like real valued function F of X, is said to be analytic at a point Z0. Z0 is a fixed complex number. At that point, we are saying the function F of Z is analytic. The condition has to satisfy is the same function F of Z is differentiable at that point, but also differentiable at every point in some neighborhood of Z0. It is difficult to understand some neighborhood of Z0. So just I will show geometrically. Let us take Z0, that is a center, that is a point. Z0 represents a point, okay, in the orgone plane, complex plane. So by taking this point as a center, we can draw so many circles. So if there exists a circle, at Z0 is taken as a center, inside the circle, there are so many complex numbers Z. The blue shaded part, that is inside a circular region having center at Z0, if the function F of Z is differentiable, that is F of Z is differentiable at every point inside The some circle having center z0, okay, with a radius anything. So when we take a point as a center, so many circles we can draw. We have to find a sum circle. That means one circle for which at every point inside that circle, the function f of z is differentiable. Then only we can say the same function is analytic at a point z0. It is difficult to understand analytically or geometrically. Now, a complex valued function f of z is said to be analytic in a region R. In a region R means, now this slideshow is a rectangular region. There are so many points z. At every point z in the region R, the function f of z is analytic. Then only we can say the analytic in a region R. So please underline the words analytic. That is also called or f dash z exists at every point z belongs to the given region R. R is not real numbers. It is some region, rectangular region or square region, anything. Now, an analytic function, that is other names for analytic function, regular function or holomorphic function or monogenic function. So they can ask the question, find the analytic function. Instead of analytic function, they can ask other names, regular function, etc. Okay, please remember. So moving to next slide. Now, if a function f of z is analytic at every point in the complex plane, other name for complex plane is organ plane, that is z plane, the whole entire plane. Okay, at every point the function is analytic. Such a function is called entire function. In 2019, this one more question asked, which one of the following options are entire functions? Example, constant function, everywhere differentiable in the complex plane. Polynomial function, z, z square, z cube, etc. Exponential function, e raised to z. Trigonometric sin z, cos z functions. Hyperbolic sin hz, cos hz function. These are the standard examples of entire function. So you know that sin hz, just like sin hx, e raised to z minus e raised to minus z divided by 2. And cos hz is e raised to z plus e raised to minus z whole divided by 2. Now, the two scientists, Cauchy-Riemann, simply called CR equations. What is the use? What is the purpose of this? For example, if I take a function, f of z is equal to complex valued function x square minus I times y square. I is imaginary. How do you say this is analytic or not? So at every point in a given region, finding analytic function or finding f dash z, okay, it is a tough task. It takes more time or sometimes doesn't exist to find f dash z. Doesn't easy to find f dash z because these are Cartesian coordinates, but the function is z variable. We can't convert into this z variable function. Okay, to say f dash z, just like real variable techniques. Okay, that is real variable f dash x procedure. Here also we can say, we can use f dash z procedure provided f of z is analytic. So for these type of problems, it is difficult to find f dash z at every point in the region. So these scientists, they have given the very easiest procedure to say the given complex function is analytic. Okay, so the necessary and sufficient conditions that w is equal to f of z, that is w is a function of z and is nothing but a complex variable expressed as u plus iv. Both the three are same meaning. To be analytic in a region are that two conditions, for which second condition is very, very important. The four partial derivatives, dou u by dou x, comma dou u by dou y, comma dou v by dou x, comma dou v by dou y, all these are exist, that means giving a finite value, and are continuous in the same region. Or you know the meaning of geometrical meaning of continuity of function. These are all Cartesian coordinates. We have learned in the real variable system, continuity, exist, partial derivatives, all these things. Second condition, dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. These two equations are called CR equations or Cauchy-Riemann equations, simply CR equations. So we know that some standard functions well remembered in real systems which are always continuous and partial derivative exist or not. Okay, that is previous calculus topics. Now these are Cartesian coordinates x comma y. Similarly, there is a procedure in polar coordinates. Usually polar coordinates denoted by r comma theta. So Cauchy-Riemann equations in polar coordinates are dou u by dou r is equal to 1 upon r dou v by dou theta. So this is r. And dou v by dou r is equal to minus 1 upon r dou u by dou theta. Okay, so please modify this. The first box is dou u by dou r. So this is asked in 1 mark question, statement question, not problems. But these two boxes many times asked regarding problems as well as formula based questions. Next. So suppose this again, this example, if we proved it is analytic, how do you find f dash z? Do you think the procedure like that, x square derivative 2x and y square derivative 2y? It is not like that, absolutely wrong like that. Then these scientists, they have given a easiest procedure for finding f dash z provided f of z is analytic. So if w is equal to f of z is equal to u plus iv is analytic, then dw by dz, just like dy by dx, is equal to f dash z, just like f dash x in real variables, is equal to simple answer. For this u comma v, apply partial derivatives with respect to x. So you will be getting dou u by dou x plus I dou v by dou x. These are Cartesian coordinates. Similarly, in polar coordinates, f dash z is equal to e raised to minus I theta into dou u by dou r plus I dou v by dou r. So please remember, the boxes are very, very important in case of problems. Please by heart. Okay. Now just like this is fluid mechanics, and for technical subject, that is electrical and AC also, every stream, instead of f of z is equal to u plus iv, they have given this w is equal to phi of x comma y plus I times psi of x comma y, instead of u of x comma y, v of x comma y, represents complex potential function. Just it is a technical oriented topic, complex potential function. Previously it is analytic function mathematically. So here phi is called velocity function and psi is called stream function. Just like previously, phi is real part, psi is imaginary part. So later I will discuss construction of analytic function after doing 1 or 2 examples. Let us do 1 or 2 examples. This is a gate question. An analytic function of a complex variable z is equal to x plus iy is expressed as f of z is equal to u of x comma y plus I times v of x comma y, where I is equal to root minus 1, full stop. If u is equal to xy, that is real part given, the expression for v should be, that means we are going to find v value, 4 options given. So we can do such type of problems by 2 methods. Method 1 is direct method. Method 2 means indirect method, that is options method. So solution, u given x into y and v is equal to question mark. Just like from partial derivatives, we remembered well total derivative definition. dv is equal to, when v is both u and v are functions of x and y. So when we have f is a function of x and y, then df is equal to, derivative of f is equal to dou f by dou x into dx plus dou f by dou y into dy. Just like we can use that result. dv is equal to dou v by dou x into dx plus dou v by dou y into dy. So we don't know these two because we are going to find. So take the help of Cauchy-Riemann equations. Dou u by dou y is equal to minus dou v by dou x. So this dou v by dou x is equal to minus dou u by dou y into dx plus dou v by dou y is nothing but dou u by dou x. So plus dou u by dou x into dy. Since from Cauchy-Riemann equations EQS. So I will back to that. This is dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. So already u given. For u, partial derivative with respect to y means x constant, y derivative 1. So this simplifies minus x times dx plus partial derivative of u with respect to x, y constant, x derivative 1. So this gives y dy. Now this looks like variable separable, or just like in vector calculus and differential equations, whenever left hand side is derivative of some function v, the right side you should express derivative of some other function. After integrating, both derivatives got cancelled, you will be getting the answer. So this is x dx is the derivative of x square by 2. So d of minus x square by 2 plus y dy can be written as derivative of y square by 2. So integrating, that is finally this is dv integrating both sides, you will be getting v is equal to integration derivative got cancelled minus x square by 2 plus y square by 2. So I can add constant k because all options containing constant k. So this is nothing but y square minus x square whole divided by 2 plus k. Accordingly, answer is option C. So method 2. At home, I will give the hint. Later you practice. U is given. We are going to find v. That is v is equal to question mark. Denote each option by v, comma, whichever satisfies CR equations that means that option required answer. So for option C, already dou u by dou x is y, dou u by dou y is x, dou v by dou x, y constant, y square by 2 0, x square derivative 2x, 2 cancel minus x, and dou v by dou y, x square by 2 0, y square derivative 2 by 2 cancel. So dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. Okay, this is the next question. This is also gate question. Consider the analytic function f of z is equal to x cube minus 3xy square plus I into 3x square y minus y cube of the complex variable z is equal to x plus iy. The derivative f dash z is equal to 4 options given. Solution. All the options in terms of z. Okay. So usually the complex valued function denoted by u plus iv, that is w is equal to f of z is equal to u plus I into v, where u is equal to x cube minus 3xy square and v is equal to 3x square y minus y cube. We know that kt means know that f dash z already given analytic function f of z. So I can use the formula for f dash z, where f of z is analytic, that is dou u by dou x plus I times dou v by dou x. What is with respect to x derivative? 3x square, that is for u, partial derivative with respect to x cube derivative 3x square, and 3xy square derivative minus 3y square plus I times dou v by dou x. So for v, partial derivative with respect to x, that is 6xy minus y cube constant 0. So this, in all this, I can take 3 common. After that, x square minus y square can be written as plus I into y whole square. I square value minus y, minus 1, plus 2 into x into iy. I can write the remaining 3xy with I can be written like this. So the 3 terms of the bracket is looks like a plus b whole square 3 times x plus iy whole square. So this is x plus iy is z, 3z square. So integrating comma f of z is equal to 3z square integration is 3 times z cube by 3 is equal to z cube. So accordingly answer is option D. But without converting into z, there are 2 scientists, Milne-Thomson, given that easiest procedure for finding this f of z directly in terms of z. Okay, whether u is given or v is given, or just like f of z is equal to u plus iv is given, we will be getting directly in terms of z. Okay, so that is this type of problem. Before that, what exactly? Milne-Thomson method. Construction of analytic function using Milne-Thomson method. That means what exactly this gives? Either real part u or imaginary part v of an analytic function f of z be given, then we can find f of z in terms of z directly without x and y terms. They won't provide f of z function. They provide either u or v. Suppose the real part u of an analytic function f of z is equal to u plus iv be given. Then we can use the following procedure to find f of z in terms of z. In terms of z directly according to the options. So real part u given. Step 1. We know that f dash z dou u by dou x plus I dou v by dou x, because f of z is analytic. We can take that formula. Now, with the help of CR equation, I can replace dou v by dou x by minus dou v by dou y. Why? Because u is given, we don't know v. If we don't know v, how can I find partial derivatives for v with respect to x and y? That's why I convert it into u terms. Now, this is step 2 is important. After f dash z like this, replacing x by z and y by 0. That means put x is equal to z and y is equal to 0 in this f dash z formula. You will be getting in step 2, f dash z is equal to in terms of z. Then integrate f dash z in step 2 with respect to z. We get f of z in terms of z. And this is constant. Similarly, if the imaginary part will be given, then we can find the analytic function f of z in terms of z. So you should by heart this only, replacing x by z and y by 0. But before that, this is necessary formula for f dash z. Okay. In the previous problem, we have considered directly this f dash z, because f of z is given u plus iv. In the previous, that is second example, u given, v given. That's why I considered like this. If any one of these given, then this is the procedure. Replacing x by z and y by 0. For example, in this, if I put x z and y 0, 3z square. Got it or not? That is the Milne-Thomson method. Let us see an example. This is a gate question, 2 marks. An analytic function w of z is defined as w is equal to u plus iv, where I is equal to root minus 1 and z is equal to x plus iy. If the real part is given by u is equal to y by x square plus y square, comma w of z is 4 options given. Solution. So first find for the given u both partial derivatives, dou u by dou x and dou v by dou y. Partial derivative with respect to x means y constant. So you can apply u by v rule also, quotient rule, derivative x square plus y square into y derivative with respect to x is constant, derivative 0, minus y into x square plus y square derivative with respect to x partially gives 2x, y square 0, divided by x square plus y square whole square, that is v square. So this simplifies to minus 2xy divided by x square plus y square whole square. And dou u by dou y is equal to partial derivative with y means x constant, again looks like quotient rule, x square plus y square, y derivative with respect to y is 1 minus y times x square plus y square derivative with respect to y is gives 2y partial derivative divided by v square, that is x square plus y square whole square. So this simplifies to x square minus y square divided by x square plus y square whole square. Now f dash z formula, directly taking f dash z, that is step 1, dou u by dou x plus I times dou v by dou x. This f dash z is also written as dw by dz. So u is given, we don't know v, that's why you can't find dou v by dou x. Take the help of CR equation, dou u by dou x minus I times dou u by dou y. Since by using Cauchy-Riemann equations. So what is dou u by dou x? Minus 2xy divided by x square plus y square whole square plus I times, sorry, minus I times, or I can write this dou u by dou y now, my adjusting this minus into this, y square minus x square divided by x square plus y square whole square. So replacing x by z and y by 0, that is x tends to z, y tends to 0 means x is replaced by z, y is replaced by 0. We get f dash z is equal to y0, the first bracket becomes 0, the second bracket plus I times minus z square numerator, denominator z square whole square. One z square cancels, so minus I times z power minus 2 looks like z power n, so integrating we get f dash z after integration gives f of z, so minus I times z power n integration is z power n plus 1 divided by n plus 1 plus c. So this simplifies to I upon z plus c or plus k as you wish, but options not given plus c. So accordingly answer is option C, ignoring constant c. I hope that everyone following understood. So everyone please subscribe the channel for getting more videos. In the upcoming weeks, you have some other technical subjects, YouTube session classes. GATEFORUM providing various courses. Number 1, live internet based classes, e-gate classes, online classes, that is with expert lectures with more experience. Number 2, test series. The 3 types of tests, subject wise, chapter wise, and the whole syllabus, that is in the pattern of GATE exam, that is called target tests. And third one, the new syllabus, that is new course, refresher course, contains the concept and theory with one example each, if possible, depending on the concept, including 2010 to 2020 GATE questions along with explanations. So we'll move to the next concept, that is, here this is over, singularity. That is, a complex valued function f of z is not defined or not continuous or not differentiable or not analytic at a point z0. Such a point z0 is called singularity or singular point of the function f of z. Usually singular points of a given function f of z are obtained by equating denominator to 0. Generally where the function is not defined, just like our childhood classes where the denominator 0. So for example, find the singular points of f of z is equal to z square minus 1 by z square plus 1 into z minus 2 whole square. So here the denominator is z square plus 1 into z minus 2 whole square equal to 0. Solving this equation, you will be getting 4 values for z plus I minus I 2, 2. These are called singular points. I minus I are non-repeated. 2 is a repeated singular point. Okay. So that is a point where the function f of z fails to be analytic. That is, if f of z is not analytic at a point. If f of z ceases to be analytic at a point z, ceases means fails. Please underline. Now, this is useful in a complex integration problem, these singular points. Now, complex differentiation over, that is dou u by dx, dou u by dou y, that is CR equations, analytic, that is called first part. Now, integration part, complex integration. The first one is complex line integral, just like in vector calculus, vector line integral, here complex line integral. The vector line integral is integral over C f bar dot dr bar. That is in the previous sessions. Integral over C f bar dot dr bar, where f bar is 2 variables vector or 3 variables vector. Okay, this is a vector line integral. But complex line integral is integral over C f of z dz, only 2 Cartesian coordinates x and y, but previously vector line integral is either 3 Cartesian coordinates or 2 Cartesian coordinates. So this is the definition. The integral of f of z along a curve other name is path, denoted by C. C is a curve, is denoted by integral over C f of z dz, where f of z is defined at every point of C. We know that z is equal to x plus iy. If they do not provide, by default case, z is equal to x plus iy. What is dz? Derivative of z, that is dx plus I dy. If fz is not provided, that is complex valued function f of z is not given, usually it is again a complex variable taken as u plus iy, because z is equal to, we already took x plus iy. Sorry. Now I want to write in Cartesian coordinates. This is complex form of line integral. Therefore, integral over C f of z dz is equal to integral over C. This f of z is u plus iy. This dz is provided as about dx plus I dy. This is product of 2 complex numbers. You know product. So first collect the terms not containing I, real parts, u into dx, and this is I into v into I into dy, that is I square value minus 1. So another real part is minus v dy, put together in a bracket. So that is the finally the real part is u dx minus v dy plus I times here iv into dx. If I take I common, v dx, and this second term of the second bracket, first term of the first bracket, u dy after taking I common. This is imaginary part. So this is Cartesian coordinate complex line integral. This is original complex line integral. Now, just like vector calculus integration, if C is a closure curve, then the line integral is denoted by integral over C f of z dz. In the middle of the integral, put circle symbol. I already told you this circle means the curve is not always a circle. It may be a triangle or square or circle or anything. Now, this is important point. Just like vector calculus, if f bar is irrotational, but here f of z is analytic, then the line integral is independent of the path C. So whenever this f bar is irrotational, then this vector line integral is independent of the path C. When the curve equation is not given or curve name is not given, then how do you integrate? First, you check this function is analytic or not. If it is analytic, then take any path between the two joining points A and B, then integrate as usual, just like real variable techniques. Without integrating also, okay, if the function f of z is given in terms of z, then you should express this f of z dz as derivative of some function z, then that derivative integration got cancelled. The remaining z function is called the given line integral answer. But that is obtained by the condition f of z is analytic. Otherwise, your one of the option is f of z is that integration is depending on the path C joining 2 points. Okay. Now let us have an example by both methods, direct method and indirect method. Example. Evaluate integral over C x square minus y square plus I times dxy whole multiplied by dz. So this is your function of z, which is Cartesian coordinates u plus iv, u plus iv, where u is equal to x square minus y square, v is equal to 2xy. Along a curve name mentioned, straight line joining origin. In 2D geometry, origin means 0, 0, 1 plus I, 1 comma 1. And please remember everyone, z is equal to x plus iy is also represented by some others by just like 2D geometry x comma y or some standard textbooks x comma iy. Because of gate questions, they have asked sometimes like this. If it is 2 comma 3i, just add 2 plus 3i is a given complex number. If it is 2 comma 3, then the second coordinate you should multiply by I and then adding will give x plus iy. So C is a straight line from 0, 0 to 1, 1. Equation is y is equal to x, y. In every point, y value is same as x. So joining these 2 points, the curve is y is equal to x. Or you can use the 2-point straight line joining. x1, y1, x2, y2 is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1. Using that, you will be getting directly y is equal to x. Or logically, y is equal to x. How? In every point, x value is same as y value. That is why y is equal to x. Then differentiate dy is equal to dx. Why should we differentiate? Because dz is nothing but dx plus I dy. So this is our given line integral. dz is dx plus I dy. Now this is a 2 variables. We have only one integration. So convert if possible all are into one variable terms or express this x comma y terms as derivative of some function. Just like discussed in vector line integral vector calculus chapter. So here x square same. Y is equal to x means y square x square. 2xy becomes 2x into x 2x square. Dx is same. Dy is nothing but dx. So this is completely one variable terms. So here x square minus x will cancel. Here dx I can take common. So after taking that, this is 1 plus I and this I take out. So 2 is also getting common. Finally x square dx 2 into here I into 1 is I into I square minus 1, x square integration with respect to x cube by 3 between the limit 0 to 1. So 2 by 3 minus 1 plus I. This is the answer. Let us check this f of z is analytic or not without considering the straight line. See method 2. F of z is equal to x square minus y square plus I times 2xy. This can be written as x square minus y square can be written as I times y whole square plus 2 into x into iy. I into 2xy can be written as. This looks like a square plus b square plus 2ab. So that is x plus iy whole square. X plus iy is nothing but z. So finally f of z is z square. That polynomial function is always analytic. Exponential function in the previous slides I explained at every point. So integration is independent of the path C without taking the straight line or any path. You will be getting the answer directly. How? Integral over C f of z dz is equal to f of z is z square. Z square integration is z cube by 3. Just like real variables, x square integration with respect to x is x cube by 3. But we are using the z variable terms integration comparing with x variable terms integration provided f of z is analytic only. So substituting upper limit and lower limit, expanding a plus b whole cube, a cube plus b cube plus 3a square b plus 3ab square, I square value minus 1, I cube value minus I. Using this, so 2 by 3 into minus 1 plus I. Previous method also 2 by 3 into minus 1 plus I. Now, suppose if they ask this problem, integral over C z square minus 1 divided by z into z plus 1, where curve equation is a circle mod z is equal to 1 by 2. How do you evaluate this type of problems? So converting into Cartesian coordinates x, y, it is not easy every problem. Then Cauchy scientist, he invented two theorems which can be evaluated easily by satisfying some conditions. That is singular points condition. Let us check one by one theorem. Okay. So this is not easy by previous method, line integral method. So there are two theorems called Cauchy's integral theorem, short form CIT. Another one is Cauchy's integral formula CIF. Okay. So remember all circle equation. Mod z minus a is equal to r is equation of a circle in complex plane, comma, with center at z is equal to a is the center, and the radius is equal to r. Okay, unit circle means radius equal to 1. Default case, we are taking mod z is equal to 1 if the center is not mentioned. So what exactly Cauchy's integral theorem? It is difficult to understand, but problems are dead easy. Please, if f of z is analytic, underline, at every point inside and on a simple closed curve C. Suppose this is a closed curve C. This C is traverse, direction of the C is anti-clockwise, counterclockwise. So inside at every point Z, on the boundary on side, on the curve, that is at every point on the curve. There are so many points Z. At every point Z, the function is analytic. How do you verify? By Cauchy-Riemann equations, previous methods, analytic function method. Then integration of the function f of z with respect to z along this closed curve C is 0. This is proved or invented by Cauchy's, called Cauchy's integral theorem. Okay, let us have an example. This is a gate question. The value of integral over C z minus 1 z square plus 2z plus 2 dz, where C is mod z is equal to 1, that is unit circle, radius equal to 1, center is origin. So first find the singular points of the integrand. This is your integrand z minus 1 by z square plus 2z plus 2. So equate denominator of the given integrand is 2, 0. Z square plus 2z plus 2 is equal to 0, which is a quadratic equation in z. So z is equal to minus 2 plus or minus root over b square minus 4ac, that is 4 minus 4ac becomes minus 8 divided by 2a. 2 into 1, 2. So 4 minus 8 is root minus 4. Root minus 1 is I. Root 4 is 2. So after cancelling 2, minus 1 plus or minus I are the singular points. Of the given integrand. Okay. After finding singular points, if all the singular points lies outside the curve, then the same function is analytic at every point inside and on the curve. So according to Cauchy integral theorem, answer is 0. So how do you prove the singular points lies inside a curve or outside a curve? Substitute each singular point z value in the left hand side of the curve equation, that is here mod z. Find that value. If the left hand side value greater than the radius, then the singular point lies outside the curve. If the left hand side value less than the radius, then the singular point lies inside the curve. Just like in coordinate geometry 12th standard circles chapter, when the point Px1, y1 lies outside the curve's circle S is equal to 0, inside the circle S is equal to 0, on the circle S is equal to 0. S11 greater than 0, S11 is equal to 0, S11 less than 0. You remembered or not? Like that only. So, if I put mod, that means minus 1 plus I, minus 1 minus I, both here modulus of minus 1 plus or minus I root over 1 plus 1 root 2 value greater than 1. So, please remember modulus of x plus iy is equal to root over x square plus y square. So, both lies outside C. C equation is mod z is equal to 1. Since mod minus 1 plus or minus I is equal to root over a square plus b square, that is x square plus y square, root 2 greater than 1. This is radius, right side. Left side is mod z value. Because circle equation is mod z is equal to 1. So therefore, the singular points are not lies inside or on the curve. That is f of z. Singular point means the function is not analytic at that point. So that point lies outside means at every point inside on the curve it is analytic automatically. F of z is equal to z minus 1 divided by z square plus 2z plus 2 is analytic at every point z inside and on C. Therefore, by Cauchy's integral theorem, CIT, integral over C, f of z dz is equal to 0. But it is easy or difficult, you only check converting into Cartesian coordinates and circle equation, do later. Okay, whether it is getting 0 or not, or easy or difficult. This is the wonder of Cauchy's theorems, Cauchy integral theorem. When any singular point lies inside the curve, that theorem is called Cauchy integral formula. That is the next one. Cauchy's integral formula, short form CAM. So if f of z is analytic, again underline analytic, at every point inside and on a simple closed curve C, and A, it is a special point inside C, then number 1, integral over C, f of z divided by z minus a dz. So here the left side, what is our integrand? F of z divided by z minus a. What is our denominator? Z minus a. Equate to 0, you will be getting z is equal to a singular point. If that point, singular point a inside the curve, then this integrand integration value is equal to 2 pi a into f of a. Where the numerator function is f of z, the denominator should be in the form of z minus a factor. If that z minus a is with respect to power 2, power 3, any power, natural number, then these are the results helpful. Second one, integral over C, f of z by z minus a whole square is equal to 2 pi I by 1 factor f dash a. Similarly, integral over C, f of z by z minus a whole cube dz is equal to 2 pi I by 2 factor f double dash a, and so on. In the both results, above results, C is traversing counterclockwise. That means anti-clockwise or positive direction. Let us see an example. Please by heart or remember these boxes. Okay, this is a great question. The value of the integral over C, here circle symbol is missing, but sometimes they will provide only integral over C or integral over C, middle of the integration circle symbol. Don't worry, they're remembering here mentioned closed curve. Cos 2 pi z divided by 2z minus 1 into z minus 3 dz, where C is a closed curve given by mod z is equal to 1 is. 4 options given. So this is unit circle. Comma, center is origin. Two variable origin 0 0 or z is equal to 0. Now solution. Radius 1. So first this is your integrand cos 2 pi z divided by 2z minus 1 into z minus 3. So denominator 2z minus 1 into z minus 3 equal to 0. You will be getting 2 points. Z is equal to 1 by 2 comma 3. So if I put half here, mod half is half, half less than 1. So this half is lies inside C. So first of all, both are singular points. SP means singular point. Short form of singular point can be written as SP. If I put Z is equal to 3, here mod Z, mod 3 is 3, 3 greater than 1. So this is lies outside C. So it is a mixed case problem, but our interest is inside. Whenever a point is inside, such a singular point denoted by small a. Ignore the outside points. So therefore, the given integral can be adjusted as cos 2 pi z divided by 2z minus 1 into z minus 3 dz. This can be expressed as, I can take 2 outside from 2z minus 1 can be written as z minus half, that 2 is outside, half times integral over C cos 2 pi z. The z minus 3 corresponding factor gives z is equal to 3 singular point, which is lies outside. So keep it in the numerator. This is your new numerator, whole divided by z minus half dz. Now this looks like the singular point half a lies inside. This numerator is cos 2 pi z divided by z minus 3 is f of z. So this is entirely this box. Integral over C f of z divided by z minus a. I can put circle symbol also. Now what is previous answer? 2 pi I into f of a. So this is equal to 2 pi I f of a value 1 by 2. So all these are multiplied by half times. Since by using CAF, Cauchy integral formula. And how do you get f of half? Putting z is equal to 1 by 2 in the f of z, that is cos 2 pi into 1 by 2 becomes cos pi divided by half minus 3. Cos pi value minus 1, half minus 3 is minus 5 by 2 will become 2 by 5. Fraction will be inverse when it goes to numerator. So this simplifies 2 to cancel, 2 pi I divided by 5. Accordingly, answer is option C. I hope that everyone following understood. Now we'll move to practice questions. Potential function phi is given as phi is equal to x square minus y square. What will be the stream function psi with the condition psi is equal to 0 at x is equal to 0 is equal to y? So usually u is denoted by phi function, v is denoted by psi function. The real part u is now called velocity function, potential function. The imaginary part v is now called stream function. They are asking v. Okay, so I am doing here. So psi is equal to question mark. According to total derivative definition, d psi is equal to dou psi by dou x dx plus dou psi by dou y dy by total derivative definition from partial derivatives. So phi is given. Convert into phi partial derivatives with the help of CR equation. Dou phi by dou x is dou psi by dou y. Dou phi by dou y is minus dou psi by dou x. So this is minus dou phi by dou y into dx plus this is dou phi by dou x into dy. Since by using CR equation, that is Cauchy-Riemann equation, just replacing phi by u, psi by v, you will be better understanding. So from this, d psi is equal to partial derivative of phi with respect to y, x square 0, so minus 2y into minus plus 2y dx plus partial derivative of phi with respect to x, y square 0, so x square derivative 2x dy. It looks like 2 times y dx plus x dy. So derivative of xy, I can write directly d psi is equal to derivative of 2xy, product 2. So integrating, comma, we get both the derivatives, both sides cancelled, 2xy plus c. So how do you find this c? Using the given conditions, using psi 0 when x is equal to y is equal to 0 implies c is equal to 0. Therefore, psi is equal to 2xy. This is the required answer. Accordingly, answer is option C. Now let us see the second example. If v is equal to x square minus y square by x square plus y square be an imaginary part of an analytic function f of z is equal to u of x comma y plus I times v of x comma y, then f of z is equal to, according to the options in terms of z. So this is the meaning of finding f of z in terms of z. Sorry for disturbance. Hello. So there is a power cut problem. Sorry for disturbance, everyone. So x square plus y square into x square minus y square derivative with respect to x is 2x minus x square minus y square into x square plus y square derivative with respect to x is 2x divided by denominator square, that is x square plus y square whole square. So this is equal to 2x cube. 2x is taken common, and this is 2y square x square plus y square whole square x square minus x square cancelled, y square plus y square 2y square. Similarly, dou v by dou y is equal to x square plus y square into minus 2y minus of x square minus y square into plus 2y divided by x square plus y square whole square. So after taking 2y common, minus y square plus y square cancelled. So this is minus 2y into 2x square divided by x square plus y square whole square. So this is, kindly excuse me, everyone. There is a typing mistake. If I consider directly x square minus y square by x square plus y square, no option is matching. So just I am changing that v value, the numerator, for everyone, kindly excuse me. So v is x minus y. All of you please modify. You can consider the same, but no option is matching. So ignore this square. X minus y only. So please consider v is equal to x minus y by x square plus y square. Then only you will be getting one of the option is the answer. Suppose in exam, if no option is matching, then everyone gets full marks. So dou v by dou x, x square plus y square quotient rule derivative, x square plus y square into x minus y derivative with respect to x is 1 minus x minus y into x square plus y square derivative with respect to x is 2x divided by x square plus y square whole square. So this simplifies to y square minus x square plus 2xy whole divided by x square plus y square whole square. So similarly, dou v by dou y, you will be getting y square minus x square minus 2xy whole divided by x square plus y square whole square. Please check. So we know that f dash z by Milne-Thomson method, dou u by dou x plus I times dou v by dou x. So this is v is given. We have to eliminate dou v by dou x by the help of CR equation. So dou u by dou x is equal to dou v by dou y plus I times dou v by dou x. Since by Cauchy-Riemann equations. So in this next step, let x tends to z as discussed in the previous 4 questions. X is replaced by z and y is replaced by 0. We get f dash z is equal to, the first bracket is dou v by dou y. So in this dou v by dou y, y square 0 minus z square by z square whole square. Denominator is z power 4 plus I times dou v by dou x in the above dou v by dou x, putting y0 x z, you will be getting same again minus z square by z power 4. So minus common, 1 plus I common. After cancelling z square, it becomes z power minus 2. So integrating, we get f of z is equal to 1 plus I by z plus c, because z power n integration with respect to z is z power n plus 1 by n plus 1, provided denominator not equal 0. We can use the procedures of integration of real variable techniques, provided f of z is analytic. So which option? 1 plus I by z plus c. So accordingly, answer is option B. So after changing this, after ignoring these squares of the numerator x and y terms, you will be getting the option. You need not worry. If you consider as it is the given x square minus y square by x square with y square, you will be getting same I mean, you will be getting the answer, but which is not in the options. You don't worry about that options. So this is third example. According to complex integration, Cauchy integral theorem, Cauchy integral formula, let us check. The denominator equal to 0, z is equal to -1 and z is equal to 2 are the singular points. It is not easy by converting into Cartesian coordinates, z is equal to x plus iy and integrating. So if I put here -1, this lies outside C. And if I put 2 here, 2 minus 1, 1 minus I modulus is root 2 less than 2. So lies inside C. You can verify just like in previous procedures. So only mixed case problem, one singular point. So this point is inside. Let us denote that is by A. Therefore, integration over a closed curve C. This is a circle. Curve is a circle with a center at 1 plus I, radius 2. Mod z plus 4 divided by z plus 1 into z minus 2 whole cube dz can be written as integral over C z plus 4 upon z plus 1. These two terms by putting bracket and the second denominator z minus 2 whole cube, just like a by b by c can be written as a by bc, our childhood integral formulas. That means fraction simplification formulas. So now this is comparing with 2 is z minus a whole cube. This new numerator z plus 4 by z plus 1 is our new function f of z. According to Cauchy integral formula, this is 2 pi I divided by 2 factorial second derivative of f of z at z is equal to 2. Since by using CIF. See, let us go back to that explanation. This is okay. Now 2 factorial 2 cancel. What is f of z? F of z can be written as the numerator z plus 4 can be written as z plus 1 plus 3. So 1 plus separating into fraction 1 plus 3 by z plus 1. Can I write like this? After taking LCM, you will be getting z plus 4 by z plus 1. So first derivative 1 by x derivative is minus 1 by x square. So this becomes minus 3 by z plus 1 whole square, or you can apply quotient rule differentiation. Again second derivative, that is f double dash z. This becomes 6 by z plus 1 whole cube. So this is the explanation part. Go back, come to this step, 2 factorial 2 cancel, pi I multiplied with f double dash 2. In this f double dash z, put z is equal to 2. So 6 by 2 plus 1 whole cube. 1 3 is cancelled, 3 cube 27. So 2 pi I by 9. Accordingly, answer is option B. So this is logical question problem that is based on basics. That is complex numbers 11th standard after trigonometry. In the end of the trigonometry chapter, you have complex numbers problems. So using that. So do you all remember that De Moivre's theorem, cos theta plus I sin theta whole to the power square, cube, whole power 10, whole power half, whole power n. That power n should multiply with angle theta. So cos n theta plus I sin n theta. N is any number. Okay. So like this, z power 10. First find z square by x by using a plus b whole square, and then z power 4. By using this direct method calculation, the problem becomes more time tedious. That is time consuming problem. So express this z as polar coordinates. Root 3 by 2, 1 by 2, cos theta, sin theta, where the angle coincident cos 30 degrees. Cos 30, root 3 by 2, sin 30, 1 by 2. So cos pi by 6 is called 30 degrees. Pi is 180 degrees. I into sin pi by 6. Therefore, z to the power 10 is equal to cos pi by 6 plus I sin pi by 6 whole to the power 10. That power 10 multiplied with pi by 6 will become 5 pi by 3. Cos 5 pi by 3 plus I times sin 5 pi by 3. 5 into pi by 3 means 560. 300 means fourth quadrant. In fourth quadrant, cos is positive, sin is negative. So just looks like cos pi by 3 and sin pi by 3. but positive and negative, remember. So cos 60, 1 by 2. Sin 60, root 3 by 2. Minus I times root 3 by 2. You later check by direct method, z square, z power 4, then z power 8, multiplied with z square. 4 steps, you will be getting the answer. Half minus I times root 3 by 2. Or cos 360 minus theta is cos theta. Sin 360 minus theta is minus sin theta. Cos 2 pi minus pi by 3 is nothing but cos pi by 3. Sin 2 pi minus pi by 3. 2 pi minus pi by 3 simplifies to 5 pi by 3 minus sin pi by 3. Pi by 3 means 60 degrees. Sin 60 root 3 by 2, cos 60 1 by 2. So the value is half minus I times root 3 by 2. I'm ending the session. All the mathematics YouTube sessions topics over. Wish you good luck. Thank you. Please subscribe the channel for everyone for getting more videos. Once again, thank you to all. Wish you good luck. Wish you best of luck for your bright future. Before that, your coming GATE exam, 2021 GATE exam. Thank you once again, one and all. Bye-bye.